Did you know that there's a link between Newton's first law, Newton's second law, and Newton's third law of motions? But somehow it gets so confusing to navigate from one law to another. But then just to summarize it, it works like this. So with first law, the object is at rest and then it starts to move. As it starts to move now, F is equals to ma, or F net is equals to ma. Now the force and the mass, there's a relationship there. That's the second law. And then on the third law, now the very same object, now it can collide or meet other objects and they apply forces to one another. And then now that's Newton's third law. But then that's not the point. Today, I want us to conclude on Newton's first law before we move to Newton's second law. And the selected question for today is going to help us to move softly from Newton's first law to Newton's second law. So now, without wasting time, the question that was selected for today is question 2. We're still on physics, right? So the question reads, a man faces difficulty while swimming in a dam. In my understanding, I can tell this is a black man because, swimming, dam, difficulty. But then during the rescue operation, an inflated tube attached to a helicopter by a rope is dropped from a helicopter. So now, because that man is struggling swimming there, they had to rescue the guy. So they dropped a tube that is attached to a rope. And then there's a helicopter that whereby they're supposed to help the guy come out of the dam, right? And then the man of mass 70 kg holds onto the inflated tube of mass 4 kg. So the tube itself, it has 4 kg, the man 70 kg. While the helicopter is flying horizontally at a constant speed, note one thing. The weight constant is in capital letters. That should ring a bell. There's something special about that, but we're going to get to that part when we break it down. So now an average frictional force of 300 Newton is exerted on the man-tube combination while they are dragged horizontally along the surface of the water by the helicopter. So now we are talking about a man-tube combination. If the man is 70 kg and the tube is 4 kg, now we are looking at a total mass of 74 kg. Sharp. And then the rope makes an angle of 50%. The rope makes an angle of 50 degrees with the surface of the water, as shown in the diagram below. We can see the picture on the diagram, right? And then we have to assume that the rope is inextensible and massless. Inextensible meaning it can't extend, it cannot stretch. And we can ignore the mass of the rope as well, which is very much important for a question like this. And the water of the dam does not flow as well, because now we're picturing a dam where it's a windless day. So the water in the dam is not flowing. So it's just the man himself struggling to swim up, and then they call a helicopter, throw out the tube, then he catches the tube, and then they pull him out. That's the scenario of the question. But now we have to break it down. The first question, they want us to state Newton's first law of motion, right? Now, stating Newton's first law of motion. Now, when coming to stating Newton's first law of motion, it depends. I feel like someone who's preparing for an exam, they can cram. It's like 3 lines. A body will remain at rest or continue with its constant motion unless or until a force is acted upon on the object. And then that's when it will start to move. That's Newton's first law in weights. You can Google that. For 2 marks, stating Newton's first law in weights, anyone can do that, given that you are preparing for a test or an exam. You can state that law and then the following day you forget what the law said. You can just go and read out. You can even Google Newton's first law in weights. But now that's not the point. The point is actually understanding the law. So now in weights, the law may state that a body or an object will remain at its state of rest, meaning it will not move. It will remain at its state of rest until or unless a force is acted upon the object. Then the object will start to move. That's Newton's first law. Or even if it was moving, it will move at that constant velocity or constant speed until some sort of a force is acted on the object, and then it's going to move faster to that direction of the force. And somehow, from Newton's first law, as the object starts to move, the moment the force is applied, now that's when it takes us to Newton's second law. Smarty Pants would pick it up that F net is equals to ma, right? But before we get there, I just want us to understand the first law first. So in words, you would state that a body will remain at rest, or an object will remain at its state of rest, or it will continue moving at a constant velocity or a constant speed unless or until a force is acted on that object, or a force is acted upon that object, and then it will start to move. So without a force being acted on that object, it will remain like that at its state of rest forever, if it has to be like that, until a force is acted upon. That's Newton's first law of motion. So we've answered question 2.1 like that. Now, for question 2.2, they want us to draw a free body diagram of the man-tube combination while they are being dragged. So now, after the guy grabs the tube and then the helicopter starts to move, let me put my cat down. But then that as it starts to happen, they want us to draw a free body diagram. A free body diagram, it shouldn't be complicated, guys. You just show the object, and then you show all the forces that are acting on that object, and then you name all the forces that are acting on that object. You can see if it's 4 marks, I can say it's a hint that we expect 4 mass to be acting on our object, and our object in this case is the man-tube combination. So we know the man is 70 kg, his mass alone. The tube is 4 kg, and then the man-tube combination, we're now looking at 74 kg. But then that's not the point. The real point is now to show the forces that are acting on the combination of the tube and the man, and how the whole thing goes. So now let's imagine the situation. The guy and the tube, they are here. The helicopter, this is the rope that the helicopter is pulling the guy with, and they're telling us we have average friction. Friction obviously will act to that direction, because obviously the helicopter is going that direction, so friction would act like that. Somehow we know we have the weight of Mr. Man underwater there as he's swimming there. And then we have the normal force as well. So ideally, this is how the free body diagram should look like. So for curriculum purposes, we can draw it like this. And don't forget that now we're looking at the mass of the man and the tube to be like 70 kg plus the 4 kg. So the total mass will be 74 kg as mentioned, because it's the man of 70 kg being pulled in a tube of 4 kg. So now the proper body diagram is going to look like this. We have the normal force acting up, I can call it N. We have the weight acting downwards, I can call it W. We have the force that is exerted by the helicopter, we can call it the tension, because that's where the rope is tied. And then we have the force acting at the opposite direction, can be our small f for friction. So this is our free body diagram. But to get full marks, you have to name all the forces. So you're going to name this as your tension. T is for tension, N is for normal force, N is for normal force, F is for friction, which is 300 Newtons, friction, and then W is for the weight of Mr. Man and the tube. So W is the weight. Just by doing this, you collect all the 4 marks on question 2.2. This is how you draw the free body diagram. So I can then label this that 2.2, this is the answer for 2.2. And then we have question 2.3. I'm taking my time to take a deep breath, because I have two or three students who don't like this type of question when it gets here. They want us to calculate the tension in the rope. So they want us to calculate T according to our vector diagram, the tension in the rope, right? So fine. So the ropes makes an angle of 50 degrees with the water. We can't start to calculate the tension as long as it goes like that. We want to calculate the tension when it's directly on the horizontal plane. So to move the T to the horizontal plane, we must include Pythagoras. Somehow, suppose we name the horizontal plane X. If we name the horizontal plane X, we can see that this thing somehow forms some sort of 90 degrees here. If we're to construct a line here, it would form 90 degrees here. And then we have our SOHCAHTOA from mathematics. SOHCAHTOA, meaning sine theta is equals to opposite over adjacent. Cos theta is equals to adjacent over hypotenuse. Tan theta is equals to opposite over adjacent. Now, I want to include X and T with the angle 50 degrees. Somehow I can tell that cos of 50 degrees is going to be adjacent over hypotenuse. If I've named this X, which is my adjacent, T is my hypotenuse, cos 50 degrees is going to be X over T. Cos 50 degrees, given that this is the opposite, this is the adjacent, this is the hypotenuse, cos 50 degrees will be cos 50 degrees will be adjacent over hypotenuse because SOHCAHTOA determines that. So cos is adjacent over hypotenuse. So cos 50 is going to be adjacent X over hypotenuse T. But we know that any number is over 1 anyway. So for me to get the value of X here, I can just cross multiply. If I cross multiply, X times 1 will be X as equals to cos 50 times T is going to be T cos 50. So now that's how I write the T in terms of the horizontal plane X, meaning if I fix my free body diagram now and I write it properly, it means I will have F here, I will have N here, I will have the weight here, and then I will have T cos 50 degrees. So if I want to write this T just in terms of the horizontal x-axis, is going to be like that. This is the only way I can calculate T. But now calculating T, moving forward, calculating the value of T. I know that F net is equals to MA. I'm going to use this object now because I've transformed this to that. So this is the perfect form. So F net is equals to MA, right? I'm focusing on the horizontal now. The plane is pulling the guy to that direction. The plane is going to that direction. We can all see that. So now F net is going to be T cos of 50 degrees minus the frictional force. So since it's going that side, it's going to be T cos 50 minus frictional force is equals to MA. This is what I have so far. And F net being equals to MA is taking us to some sort of Newton's second law, but then we'll explain in some other topic. Now, the part of the question where they said the plane is moving at a constant speed. Constant speed means that acceleration is equals to 0. Constant speed. For them mentioning that the speed is constant in capital letters, they were giving us a key to say that A is equals to 0. So if the speed is constant, A is equals to 0, mainly because acceleration is changing velocity over the change in time, which is changing speed over the change in time. The difference between velocity and speed is just that speed is a scalar quantity, velocity is the vector quantity. With the magnitude of the speed and velocity may be the same, but then with velocity, we care about the direction as well, whereas in speed, we don't care about the direction, it's just the magnitude. So now, I'm just pushing on the fact that A is 0, which is going to make this part to be 0 because whatever mass may be, we know the mass is 74 kg, yes, so 74 times 0 is going to be 0. Therefore, T cos 50 degrees minus F. So we have this, meaning here we can have that T is equals, or before I simplify it further, we can have that T cos 50 degrees is equals to F for frictional force. And then our final answer, it can be T is equals to frictional force divided by cos of 50 degrees. But we know what our frictional force is. Our frictional force is 300 newtons all over cos of 50 degrees. And then if we solve that on the calculator, our final answer is going to be 466.72 newtons. That will be our final answer. So we can then conclude this is 2.3. This is how you answer 2.3. So question 2.4, they want to know how will the answer to question 2.3, which we just calculated now, how will the answer to question 2.3 change if the helicopter accelerates while dragging the man? Change of the forces now. It will remain at, now stating Newton's first law again, a body will remain at rest or continue moving on the constant speed or constant velocity until a force is acted on the object. So now by accelerating, now acceleration is no longer 0. So that MA, looking at this again, if acceleration changes and becomes a specific value, I don't care what value it may be, if the acceleration starts to move, then now there's a force acting now on the body now. This means that the tension is not going to be the same value because now we're going to have a value here for acceleration. Somehow the tension may have a bigger force than it had because now the object is moving. So to answer 2.4, since they're saying choose from increase, decrease, or no change, give a reason for your answer, I would say the tension would increase. And my reason would be now the acceleration is no longer 0. So we'll have a value for the acceleration, which is going to make the tension to have a higher force than it had. So basically, that's how you answer the questions like this. So at this point, I would like to believe that everyone is ready now for us to move to Newton's second law fully. Not that I assume that we fully understand the first law, but then you will see how everything connects. Probably by the time we go to the third law, we can connect everything where it's going to make everything looks easy because that's what we do. We are simplified RSA, the guys who makes everything looks easy in this context, academical things, more or less. But anyway, I think for today, we're going to stop here. Please subscribe to our YouTube channel, follow us on Facebook, follow us on Instagram, follow us on Twitter, as well as on TikTok. Now you can access our learning channel through Spotify as well. You just have to go to Spotify app and search for the learning channel, or you can just search for the word simplify_RSA. Also, please feel free to contact us anytime to inquire about our private lessons. Our contact details are here. You can either send us an email or send us a WhatsApp text, and then we're going to assist you. Otherwise, alternatively, which is now out of financial related stuff, you can just send us a question you may have in mathematics or physics, and then we can once off contact you to help you while we are busy doing the very same thing here. Like I said, I'm Mr. Money. This is Simplified RSA. The guys makes it looks easy. Join us on the next video as we proceed with academic work.